Hello guys, welcome aboard Apex Math. My name is Bino. In this video, we go through question 1 from the 4th of August 2025 Engineering, Science and 4 question paper. Question 1.1 states that a British Airways aeroplane A leaves an airport and flies at a speed of 400 kilometers per hour due north. At the same time, another aeroplane B leaves the airport and flies at a velocity of 300 kilometers per hour, 45 degrees east of south. We calculate the velocity of aeroplane A relative to aeroplane B. We have the following Cartesian plane and we name our direction. The direction east will be positive and north will also be positive. And the direction west and south will be in negative. So we are told that aeroplane A leaves an airport and flies at a speed of 400 kilometers per hour due north. The center of our Cartesian plane will be our reference point and our aeroplane moves strictly north. It will not have any horizontal component, only the 400 kilometer per hour vertical component. So this is aeroplane A, and we are also told that another aeroplane B leaves the airport and flies at a velocity of 300 kilometers per hour, 45 degrees east of south. We have the bearing S 45 degrees east. So this means that this aeroplane B is from south and it's going to east. And it's from south is going to east by 45 degrees. So 45 degrees from south going east. But then when we calculate the horizontal and vertical component, we use the angle attached to the x. So we have to determine that angle. So that angle will be 90 degrees minus 45, which will also be equal 45 degrees. So we are going to work with that 45 degrees attached to the x-axis. So this is equal 350 kilometers per hour, and it's our aeroplane B. Remember that we have to calculate the velocity of aeroplane A relative to aeroplane B. So the velocity of aeroplane A relative to B. So we are looking at aeroplane A whilst we are in aeroplane B. So this will be equal the velocity of A minus the velocity of B. But we can use this formula now. We have to resolve the velocity of B into its vertical and horizontal components. So the horizontal component of the velocity of B will be equal the velocity of B, which will be positive 350 multiplied by the cos of, so we are going to use that angle, the one attached to x, the cos of 45 degrees. So the velocity of B, the horizontal component, will be equal 247.49 kilometers per hour. And now the vertical component of the velocity of B will be equal, so it's going down, and down the south is negative, so this will be negative 350 multiplied by the sine of 45 degrees. So the velocity of B, the vertical component, will also be equal the 247, but it will be negative, so negative 247.49 kilometers per hour. Now we have to resolve the velocity of A, the horizontal component. So since it's strictly due north, the horizontal component will be 0. So it's strictly north. So the horizontal component will be 0 kilometers per hour, and the vertical component of the velocity of A will be the whole 400 kilometers per hour. Now we can use that formula, but for the horizontal and vertical component separately. So for the horizontal component, the velocity of A relative to the velocity of B on the x-axis will be equal. So will be equal the velocity of A, the x component, minus the velocity of B, the x component. The velocity of A relative to B on the horizontal plane will be equal. The velocity of A on the x component was 0 minus the velocity of the B on the x was 247.49 kilometers per hour. So the velocity of A relative to B on the x will be equal negative 247.49 kilometers per hour. Or we can say the velocity of A relative to B on the horizontal component is equal 247.49 kilometers per hour, and that negative will indicate that we are going in the west direction. So we remove that negative and we write west. Now the velocity of A relative to B on the y component, the vertical component, will be equal the velocity of A, the y component, minus the velocity of B, the y component. And the velocity of A relative to B, the vertical component, will be equal. The y or vertical component of the velocity of A was equal 400 kilometers per hour minus the vertical or y component of B, which was that negative. So we substitute with the negative 247.49. So the velocity of A relative to B vertically or on the y will be equal 647.49 kilometers per hour, and it's positive, so it's north. We can indicate this on the compass or the Cartesian plane. We have the vertical component and the horizontal component. The horizontal component was equal, okay, I'm sorry, I forgot to include the x, to include that we are dealing with the x component. So the x component is equal 247.49 and the y 647.49. But before we can determine the direction, we determine the resultant. So the resultant, the velocity of A relative to B, will be equal the square root of the horizontal component, the velocity of A relative to B on the x squared, plus the velocity of A relative to B on the y or vertical component. And this will be squared, and this will be equal the square root of the velocity of A relative to B on the x is 247.49, and of A relative to B on the y is 647.49, and this will be squared. On our calculator, this will be equal 693.18 kilometers per hour, and this is our resultant. So we can plot it as our resultant. So this will be that resultant, the 693,18, and we have to determine that angle. So to determine that angle, so let's copy and paste. To determine that angle, we are going to use the socket tower, and on the socket tower we are going to use, so we have the y and the x, so we are going to use the tan. So we have tan theta equal the opposite, which is y divided by the adjacent, the x. So theta will be equal the arctan of the opposite, which was y, the 647,49, divided by the adjacent, the x, the 247,49. And our theta will be equal 69,08 degrees. So we can define it using the bearings. The 69,08 degrees is our direction, and the velocity of A relative to B, the 693,18, is our magnitude. So on our diagram, we have that as west and we have north there. So our 69,08 degrees is from west and it's going to north. So this will be our answer. Question 1.2 states that the velocity of a Boeing 747 aeroplane in still condition is 550 kilometers per hour. The pilot wants to fly directly west but experiences a crosswind of 90 kilometers per hour from the south. 1.2.1, we are calculating the resulting velocity of the aeroplane. We are told that the aeroplane wants to fly directly west at 550 kilometers per hour. But then the crosswind, the wind is from the south. So it's from the south is going north. So it's from the south going north at 90 kilometers per hour. And this is our wind. We denote it by the letter W, and the aeroplane by the letter A. Remember that the aeroplane intends to go directly west by 550 kilometers, but the wind is going to push it so that it takes the direction northwest. Remember that velocity is a vector quantity, so we can move the vector of this wind and join the tail and the head of the aeroplane and the wind. We have this tail to head method, and the intentions of the aeroplane and the wind will form an angle of 90 degrees. The aeroplane intends to go directly west, but it's being pushed by the wind so that it takes the path of the hypotenuse, and the hypotenuse then will be our resultant, which we denote with the letter R. So to determine the R, we use theorem of Pythagoras. So we have R squared is equal W for the wind and the A for the aeroplane. And making R the subject, our R will be equal the square root of the velocity of the wind is equal 90 kilometers per hour, and the velocity of the aeroplane is equal 550 kilometers per hour. So our R, the resultant velocity of the aeroplane, will be equal 557,315 kilometers per hour. And the answers that I have for 1.2 are very different from the ones I saw on the electronic memorandum. Question 1.2.2, we have to determine the direction of the flight to fly directly west. So if the aeroplane wants to fly directly west, it must intend to fly southwest. And when it flies southwest, the wind is gonna push it, and from pushing it, instead of going southwest, the wind pushes it and is gonna fly directly west. We do the head to tail method between the intentions of the aeroplane and the wind. And this is 90 kilometers per hour, that's the wind. And the intentions of the aeroplane, the 550 kilometers per hour. And the actual path of the aeroplane, the resultant denoted by the letter R. But we are looking for that angle theta. So on the soccer tower, since we have the opposite and the hypotenuse, we are going to use the sine. So we have sine theta is equal the opposite divided by the hypotenuse. So our theta will be equal the arc sine of the opposite. The opposite is the 90 kilometers per hour and the hypotenuse is the 550 kilometers per hour. And our theta will be equal 9,42 degrees, and we have to define the bearings. So let's copy and paste this. Let's have our compass quickly. The theta is attached from the west cardinal, so it's from the west. So we have W, it's going to south by 9,42 degrees. So we have W first and then the south, since it's from that west cardinal. So it's attached to the west direction. And question 1.2.3, we calculated the time taken to cover 720 kilometers. So we are going to use the resultant velocity, not the intended velocity of 550. So the formula to calculate, we have speed is equal distance divided by time, making the time the subject of the formula. We have t is equal distance divided by speed, where the distance is 720 kilometers and the speed is the 557,315 kilometers. So we use the resultant, the actual speed, and 720 divided by 557,315 is equal 1,29 hours. So this will be our answer. Question 1.3 states that a shell is fired with a muzzle velocity of 850 meters per second at 25 degrees to the horizontal. We calculate the horizontal displacement or distance of the shell after 12 seconds. We have a shell fired at an angle and we want the horizontal displacement. So if that is the shell that is fired at that angle of 25 degrees and it's fired at 850 meters per second. So this meters per second is at an angle, but we want the horizontal displacement. So we have to resolve this 850 into its horizontal component. So Vx or V horizontal will be equal to V multiplied by the cos of theta. By substituting, we have the velocity of the x, or the horizontal velocity, will be equal 850 multiplied by the cos of 25 degrees. The horizontal velocity will be equal 850 multiplied by cos 25, which is equal 770,36 meters per second. So we have speed is defined as the distance divided by time, but we want the distance, so distance will be equal speed multiplied by time, but the speed is equal 770,36 multiplied by the time, which was 12 seconds. The distance, or the displacement, will be equal 9,244,32 meters, but in kilometers this will be equal 9,244 kilometers, and this will be our answer. Question 1.3.2, we have to determine the height of the shell after 12 seconds. So the height deals with vertical motion, so we resolve the velocity to its vertical component. So Vy will be equal to V multiplied by the sine of theta. So Vy will be equals to 850 multiplied by the sine of 25 degrees. And the velocity y component will be equal 359,23 meters per second. So we use the equation of motion. The equation of motion that we are going to use is S is equal u multiplied by t, u for initial velocity, plus half multiplied by a multiplied by t squared. So the u is the initial velocity, which is equal that 359,23. So we have 359,23 multiplied by the time, which is 12 seconds, plus half multiplied by, I'm sorry guys, I was supposed to choose direction. So up will be positive, just like that. 359,23 was positive, and down will be negative. So the gravity, the negative 9,81, the force of gravity will be negative since it's going down, and the time was 12, so we have 12 squared. So this displacement will be equal 3,604,44 meters. We can convert this to kilometers by dividing by 1,000. So this will be equal 3,60 kilometers. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content interesting.